let's take a broader view of what we just did. We have two ingredients here that are going to lead to an interesting and crucial abstraction called map. First, we have a set of elements that we'd like to process. In our example, this set is an array of 64 floats. Second, we have the ability to write an arbitrary function that runs on one element. In our example, our function squared each of its input elements, producing an output element. Generically, what we did was apply our function to each element in the set. This is a powerful parallel operation. So to be precise, when we talk about this, we say that we have an abstraction named map. It takes two arguments, a set of elements and a function that will be applied to each of those elements. Map is a key building block of GPU computing. Many of the problems you will solve as a GPU programmer, and certainly many of the ones in this class, use map operations. GPUs are good at map for two main reasons. One, GPUs have many parallel processors. The GPU is efficient at delegating the computation of individual elements to those processors. We're going to find out more about that soon. Second, GPUs optimize for throughput rather than latency. So as a programmer, you're probably more interested in optimizing the rate at which entire map operations can complete instead of the time it takes for any individual element to complete. And the GPU agrees with you. Let's also take a look at the communication pattern for a map operation. Map's model is straightforward. One element in, one element out, with the computation of output element number n only dependent on input element number n. This is a very simple and straightforward communication pattern. Other computations might require a more complex communication pattern, and we'll learn about those patterns over the next few units. So to make sure we understand map, let's do a little quiz. Check the problems that can be solved using a map operation on an input array. Sort, add 1 to each element in the array, sum up all the elements in the array, or compute the average of the elements in the input array.